Hi, everybody. I'm Ms. Lee. You should know that. We're talking about the Fundamental Theorem of Calculus 2 today. So I know we haven't gone over the Fundamental Theorem of Calculus 1. We'll do that next week. But we'll go ahead and talk about the Fundamental Theorem of Calculus 2, which is how you evaluate definite integrals. Okay, so let's go ahead and write that down. Fundamental The Fundamental Theorem of Calculus, part 2, and this is how to evaluate definite integrals. Okay, so the Fundamental Theorem of Calculus 2 states that as long as your function is continuous, so if f is continuous on some interval a to b, then if you want to evaluate the integral from a to b of f of x dx, then you take big F of b minus big F of a, where big F is any antiderivative of f. That is to say, a function such that the big F prime is little f. Okay, so what this theorem basically is saying is if you were given an integral, a definite integral that you wanted to evaluate from a to b, you can find the antiderivative or any antiderivative of f, which is big F, and then just do f of b minus f of a. So you plug in b and a and you subtract. Okay, so let's go ahead and do an example of this. So we're going to evaluate the integral from 0 to pi. So notice that I'm reading it from the bottom limit or bound, the top limit or bound. So the integral from 0 to pi of sine of x dx. So your first step when doing a definite integral like this is you go ahead and you find an antiderivative. Okay, so find an antiderivative of f of x, the integrand. Okay, so just a reminder, the integrand is sine of x. Okay, so when it says an antiderivative, it means you can find any antiderivative of it as long as it works. So basically you can add any constant you want. But of course, since we're working with like subtracting and things like that, it's not going to matter. But to make things easier, we're going to choose 0. So we'll find an antiderivative of sine of x, and then we'll just do plus 0. Our constant is going to be 0 so that we don't have to write it. So the antiderivative of sine of x is negative cosine of x, and then plus some constant, so plus c, but we'll just use negative cosine of x, and we're going to evaluate this from 0 to pi. Okay, so this is how we write the notation for when you've already found the antiderivative. So once you've found the antiderivative, you do not want to write the integral sign anymore. You can also write it as a bracket. So you can write negative cosine of x in the bracket, and then you write 0 to pi like this right here. Okay, so those are the two possible notations. They're the same thing. And then our next step is just plug in a and b and subtract. Okay, so we'll go ahead and do negative cosine of pi. That was plugging in the top bound. So this is f of b minus, and then we plug in the bottom bound. So we'll put it in parentheses just so that we are clear about the sign. So it'll be negative cosine of 0. Okay, so just a reiteration of which one goes where. This pi was the b, that was the top bound. So that was the b. And then the 0 was the bottom bound. The 0 was the bottom bound. Okay, so 0, 0, 0. And that was A in terms of the general definition here. That was A. Okay, so plug in A and B and subtract. So then now we just have to simplify. So we do negative cosine of pi. Well, cosine of pi is going to be -1. So negative, -1, that's +1. So negative, -1 minus, and then negative cosine of 0 is 1. And so you have negative, -1 minus -1. So that's 1 plus 1, which is 2. And so this evaluates to 2. Okay, let's go ahead and do some practice. Happy day.